Hello Geotech Masters, welcome back to our comprehensive standard penetration test or SPT. I'm thrilled to continue guiding you through the intricacies of this vital geotechnical investigation method. In our previous video, we began our deep dive into the split barrel sampler, the very heart of the SPT. We discussed its standard dimensions, the materials it's typically made from, and its essential features like the ball check and vent. We also briefly touched upon its design specifications. Now, with that foundational knowledge firmly in place, we are ready to build upon it. We are going to explore the critical components of the split barrel sampler in much more detail.
Have you ever wondered, what are sampler liners, and why do they have such a significant impact on your end values? How do different drive shoes affect the test, and what are the standard requirements? When and why are retainers used, and do they influence the penetration resistance? And, most importantly, why is meticulous sampler maintenance absolutely crucial for obtaining trustworthy data? Understanding these elements is paramount for any civil or geotechnical engineer working with SPT data, as they directly influence the test's outcome and the subsequent engineering analysis. So, let's begin our exploration. Now, why are these liners important? In our previous video we discussed that the use of an upset wall sampler is known to improve sample recovery. This is because it reduces friction on the soil core as it enters the sampler, especially in denser soils. This means you get more of the soil sample for identification and classification purposes. However, here's a critical point for engineers: liners can significantly affect the N value, or blow count. International practice often favors the original use of a constant inside diameter sampler, meaning no upset wall or liners. Limited research suggests that N values can differ by as much as 10% to 30% between a constant inside diameter sampler and an upset wall sampler. Specifically, the constant inside diameter sampler, which doesn't use liners, generally provides higher N values. This difference is more noticeable in denser soils where internal friction buildup inside a constant wall diameter sampler plays a larger role. For blow counts exceeding 10, meaning N is greater than 10, a correction may be necessary. Corrections become